All right, let's see. Let's go ahead and start infinite sequences and summation notation. This is 9.1 in your textbook. First of all, infinite sequences are very much included in calculus, and so is summation notation. So, with that said, I'm going to get a little pen ready to go just in case. I'll minimize that, and I'll move that down. All right, infinite sequence. Those are sequences that go on like forever. And the two main words for an infinite sequence. One word is converge, which means it goes to a point. And the other word is diverge, which means it does not go to a point. Does not go to a point. Okay? Summation notation. Sigma, it's a Greek letter, it means sum. And you have your equation right here, usually f of x. And you got your starting point down here and your ending point up here. Okay? That's sigma notation. So we got a lot of things to talk about on how to do this. We're also going to use the TI on how to enter this stuff. So make sure you have that out and have that on, and we'll go through it as we go through this lesson. All right? So, first one, a sequence is a list of terms from a function whose domain is a set of positive integers. And the range is the output generated by the rule. Basically, that means a sequence is a term of numbers separated by a comma. And positive integers means that you have to start with n equals 1. You can have negative numbers in the sequence, but you can never put a negative number into the rule to get a number out. Okay? So a sequence is on the list right now. So here's an example, a sub 1. That means first term. Some other things. Obviously, the 4 means the fourth term. The A's just stand for any variable. You could have x sub 1. You could have n sub 1. A's is just used in this textbook, so it's not a big deal. So that means fourth term. This means the nth term. This is usually your equation. Equation is in this one. Okay? You have an nth term equation we're going to talk about. And then the one after n is n plus 1, the next term. Make sure you jot those down because the hardest thing about sequences is how the subscript works, how this writing works and everything. So make sure you have that written down and make sure you know what it means. On your calculator, those that have a calculator right now, if you go to if you hit your, right here, on your TI, if you hit your second, and then you hit your stat button, which gets you into list, which is what you want to be. If you hit second, and then list, and slide your cursor over to ops. On my calculator, it's option number 5. It says sequence. Okay, we're going to be using that later. All right, that's on my calculator. Second list stat ops number 5, and it'll come up with sequence. Okay, we'll use that in a little bit. Make sure you write down where you can find that. I'll go through that again later. All right. So, first one, n squared plus 1. Remember, this is your rule. This equals a sub n. So the first term is when you put in n equals 1, n equals 2, n equals 3 is your third term, and n equals 4 is your fourth term. So a sub 1 equals 1 squared plus 1 equals 2. A sub 2 equals 2 squared plus 1, 5. A sub 3 3 squared plus 1, 10, a sub 4, 4 squared plus 1, 17. All right, so the sequence is going to be 2, 5, 10, and 17. Okay? That's the long and the short of it. And that's how you do it. You just put in 1, 2, 3, 4, 5. You come up with 2, 5, 10, 17. That 26 shouldn't be there. That should not be there. That's the fifth term. Okay? So, on your calculator, go to second, list, second, list, ops, sequence, and press enter. Type in x squared plus 1, comma x, comma 1, comma 4, and press enter. X squared plus 1, comma x, comma 1, comma 4, and enter. And you should get out 2, 5, 10, 17. And on TIs, it always goes sequence, your rule, your variable, your lower bound, and your upper bound. That's how it always goes. Rule, lower bound, upper bound. Okay? Like I said, you can do these manually or you can do them on the calculator. If you can't do it on the calculator, just do it manually. I'll answer your questions when I get back. All right, try this one. What is the 8th term of the sequence? Well, some people just put 8 into their calculator, and then with 8 squared plus 1, which equals 65. Not that difficult. Okay? Not that difficult at all. And you get 65. Okay? Questions on that? Just kidding. Moving on. Try this one. N minus 1, N minus 2, N minus 3. If you want, you can use a TI. You can do sequence, parentheses, x minus 1, x minus 2, x minus 3, x, 1, 4, close it off. You'll need that many parentheses because if you don't, you'll have an argument error. An argument error is from your lack of parentheses. See, I got 2 lefts to start off with. I got a right, a left and a right, left and a right. If it's not working, don't get upset. Just put in the numbers. Put in 1, you'll get 0. Put in 2, you'll get 0. Put in 3, you'll get 0. Put in 4, you get 3 times 2 times 1, which is 6, I guess. 3 times 2 times 1. Yeah, 6. So you can do it either way. All right? So you can do it on the TI or you can do it manually. Either way, you should be okay. All right. Moving on. Eighth term. Put in 8. See what you get. Yeah. 7 times 6 times 5. Or you could have done your calculator sequence x minus 1, x minus 2, x minus 3, x 1 to 8. And then when you get your numbers out, just scroll over by using your left or your right tab arrow, and you can scroll over and see what the 8th term is. Either way, you should get 210. All right? Fantastic. Okay, moving on. Oh, here we go. We just talked about it. For those of you who still haven't figured it out, second stat, list option, sequence. It goes the function, the variable, the first term, and the last term. I call it lower bound, and I call it upper bound. Okay? Now you can use the X, T, theta, N button, depending on what function you're set up in. Okay? But that's how to do it. And like I say, you don't have to do that if you don't want to. So, here we go. This one is a mode that I do not use. This is actually the sequence mode on your calculator, so we're going to not talk about that since I'm not there. So anytime you see this script right there, don't even worry about it. Okay? We're just going to bypass that. So, try this one. -1 to the n times 2n plus 1. You can put that in your TI. You can give it a go and see what you come up with. Okay? I'm going to walk around the room and see how you do. Okay? If you're having problems, try to have somebody else help you out next to it, knows what they're doing, or has the same calculator as you. It shouldn't be a problem. It should be fine. Okay? Anyway, the solutions you should have gotten would be -3, 5, -7, and 9. So I can give that a go. Hopefully a lot of you are doing okay with this. There's only a few that maybe not doing it. All right, the 8th term. You can put in 8. You can scroll over and put in 8. Makes no difference to me. Try to figure it out. Good. 17. Woo! All right, moving on. When you graph the sequence using 5 terms, all you're doing is plotting points. That's it. You just take the points and you plot them. I'm not going to graph it like this. The sequence we just had, we used the points. We had -3, 5, -7, and 9. So we had, if you put in 1, you got -3. If you put in 2, you got out, what'd you get out? 5. -3 if you put in 1, X and Y. 2, you got 5. 3, you got -7. And 4, you got out 9. All you do to graph these out is you just plot the points. Go over 1 and down 3. Go over 2, go up 5. Go over 3 and go down 7. 1, 2, 3, 4, 5, 6, 7. And go over 4 and go up 9. That's how you graph them out. 2, 3, 4, 5, 6, 7, 8, 9. Okay? Just plot them out like you would points. Don't connect them or anything. Just plot them out. Okay? I'm not going to do that other stuff on the TI. Like I said, it's not really that important. All right, good. Yeah, we're not going to do this. We're not going to do that. You can do it manually. Recursive definition. That is the one that has the n plus 1 in it. It's given a term and a formula, you can list the terms of a sequence. This one's kind of cool because it's kind of like dominoes. You have to know the one before it to get the next one. Okay? Here we are talking about our a sub n notation. A sub n is the nth term. A sub 1 is the first term. A sub 5 is the 5th term, so on and so forth. Okay? So, we got that all figured out. Here's how you do it. This means, you're going to see this notation a lot. This means that this is the next term. And this is your current term. So, you use this one to find this one. And it goes on like that. So every time you find one, you can find the next one, and the next one, and the next one. It's kind of cool. All right? So here's a for instance. If I had the sequence If a sub 1 was 2, that's my first term. This means to find my, this is my current term. So to find my next term, I add 3. That's what it means. So to my current term, I add 3 to find the next term. Oh, sure, it gets a little bit more involved, but there it is, the 3 terms. You add 3 to get to the next one. All right? You can do multiplying, dividing, adding, subtracting. But that's known as a recursive definition. You have to use one in front of it to find it. There's a cool way of doing this on the TI if you want. If you want to try it, it's known as an iteration. Sometimes you can do it, sometimes you can't. This equation you can do. Take your current term, press 2 and press enter on your calculator, and you get a 2. Then, above the negative sign is answer. Take answer plus 3 and press enter, you get 5. Press enter again, you get 8. Press enter again, you get 11. And press enter again, you get 14. Okay? If you keep pressing enter, it'll change. Like you used to do those old calculators. You know, people just sit in the study hall and hit the buttons and the numbers change. This is how you do it on the TI. Pretty impressive. Okay? All right. So, this is what this is talking about, the answer option on the TI. You know, you can do that. This is known as, on the TI, as an iteration. Okay? It's an iteration. You type 2 and press enter. Press plus 3 if you want to do the shortcut. So I always try to use answer. And then you press enter, 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 and that's kind of cool. That's today's cool math fun fact. Now you can sit there like other people in study hall and drool and hit your calculator, and you'll be fine. All right, try this one. First 5 terms. The current term is -2. Your next term, you get by adding 4. You can either do it on the calculator, or you can do it on pencil and paper. I don't really care. If you can't figure out one, then do the other one. There we go. -2, 6, 10, 14. I don't get it, I don't get it. Oh, baloney. I hate when people do that when I'm not there. -2 is the first one. You add 4 to get the next one. Add 4. Add 4. Never changes. That's why it's called recursive definition. Add 4. Okay? Great. Moving on. Try this one on your own. Current term is 5. Next term is a sub n plus 1. And to get your next term, you're going to multiply by 2. Shouldn't be that difficult. All right, good. 5, 10, 20, 40, 80. All right, one more. This one's a little bit more difficult. I don't think you can do this on the calculator. I think you have to do this one manually. There's a lot of n's in it, and there's a lot of a sub 1's in it. So, to do it manually, which is the only way I would do it. The first term, and this one requires just a little bit more thought. The first term is 1. A sub 1 equals, or I'm sorry, it's when n equals 1. That's the first term. When n equals 2, that means your second term is going to be, you see how you get a sub 2 right here? That means you're going to have 1 times a sub 1. Well, because 1 plus 1 is 2. So I have 1 times 6. That gives me 6 for my answer. Probably shouldn't have these ends right here. It's probably confusing people. Okay. So I do a sub 3. That means I have 2 times a sub 2, which is 2 times 6, which is 12. A sub 4 means I will take 3 times the third term, so it's 3 times 12, and you get 36. And finally, the fifth term is 4 times a sub 4 equals 4 times 36. That's 120, and 24, 144. Okay? That one's a little bit tedious. You cannot do it on the calculator. There's too many ends going around. Okay? Well, you probably could, but it wouldn't be worth all the effort to try to do it. Okay? So, the whole key is to make this a 2 to start off with, it has to be 1s. All right? And then 2s and 3s. All right, good. 6, 6, 12, 36, 144. Perfect. Moving on. A series. A series is a sequence that is separated by a plus sign. A series is a sum of a sequence. Sum of a sequence. In fact, on your TI, if you go to second, list, and slide over to the math option, option number 5 is sum. Okay? So we're going to use our calculators again for finding the sum of a sequence. That's known as a series. The sum of a sequence is known as a series. That was good. All right. Sigma is a Greek letter that means find the sum of a sequence, which is known as a series. Okay? Lots of series out there. I'll go over a couple of them today. This is your equation. This is your lower bound. This is your upper bound. That means I'm going to put 0 in for k and get negative 4. Sigma means that you add to that. So now I'm going to put in 1, negative 3. I'm going to put in a 2, negative 2. I'm going to put in a 3, a negative 1. I'm going to put in a 4 and get 0. I just put the numbers 1, 2, 3, 4, 0, 1, 2, 3, 4 in for k and wrote it out. Now, this is a series. You can have a non-positive integer to put in. Sequences you can't, but series you can't. So you just add all those up. Negative 7, negative 9, negative 10. Perfect. Love it. If you want to get fancy, you go to sum, parentheses, sequence, parentheses, x minus 4, comma, x, comma, 0, comma, 4. Okay? And hopefully you get negative 10. Nice. I think you will. Perfect. All right, so you can do it manually, or you can do it on the TI if you want. It's up to you. However you want to do it. Okay. Hopefully everything's going well with the calculators. All right, moving on. We just talked about this. Sum and sequence. Here's the shortcut keys again. We can type it out and get negative 10. Okay? Good. Try this one. Find the sum. J squared is your rule. J equals 1 to 6 is your series. And you have all the buttons you can push it on your calculator if you want. Okay, so find the sum. Good. This is a different way of doing it. No, I'm not going to do it this way. She got 91. I would do it as, remember, I'm not doing ends. So I'm going to go to sum sequence x squared x 1 6, close it off. Okay? Very good. Try another one. 7 and 102. Well, of course, there's an easy way of doing it. You could take 7 times 102, because this means you're going to add 7 up to itself 102 times. Or you can put on the TI. Makes no difference to me. So you come up with 714. And remember, we are not going to do it like this. Okay? Not using any of that stuff. All right, coming down the home stretch. If you have questions on the calculator, hopefully somebody can get them worked out. Otherwise, hopefully things are going well. Let's try this one. Oh, there's a sum sequence. All right. This is old school. These are all the theorems. This is what I used to have to do before the TIs came along. In some of your questions, these might come up. At least I showed them to you, but I wouldn't expect you to use them. When I was a kid, you had to memorize them. And this is how you did all the summations. So be thankful you had that little sum sequence button on your calculator. If not, you can always go old school. Okay? Makes no difference to me. So at least I showed them to you. I talk more about these in calculus if you're going to take that class. They're a little bit more important there. But for right now, they're just there to manually calculate things that you don't have to worry about. All right. So on this one, you can still enter it as a sum sequence. Give it a shot. Let's see what you get. Okay. Hopefully you got 16, 18, 69, 20. Okay, again, we're not doing the sequence mode on the calculator. I'm not there. And it's nothing you have to worry about. It's just a fancy way of doing this. And yeah, you should put your answer in frac mode because the question's in frac mode. Okay? Great. I think that's it. I think your homework assignment, yeah, that's it. Your homework assignment for section 9.1 is going to be, let me see if I can find it. For 9.1, your homework assignment is, come on, 9.1, your homework assignment is 1 through 45, every other odd on page 705. Okay? So, let me go back to this. Page 705, 1 through 45, every other odd. And get started working on it now, please. And you should be able to get done before you leave. All right. So page 705, 1 through 45, every other odd. If the person in my place, if they aren't working very hard or doing what they're supposed to be doing, just change that to all, and I'll collect it tomorrow for an assignment, okay? So right now it's every other odd. If you need to change it to make sure they work, then that's fine, go ahead. Okay? Great. Enjoyed the lesson. Talk to you later.